I'm really happy to introduce Jakob Pagter. I hope I did it the right Danish way. Jakob he has over a decade of experience working with MPC-based key management. He's now the VP of MPC at Blockdaemon, right?
Yeah.
And he's here to talk to us about MPC management for wallets. Right?
Thank you. Yeah, so I used to work for a company called Sepia, which was acquired by Blockdaemon a year and a half ago, and we were allowed to choose our own titles, so I thought that one sounded kind of cool, so I went with that. Blockdaemon, this is a kind of less technical talk with a more maybe corporate stuff in it. So it's a blockchain company providing hosting of nodes, providing staking APIs, and basically the infrastructure that you need when you use different types of blockchain and cryptocurrencies. Since they acquired us, they added the wallet part as kind of the third leg in their wallet infrastructure business. They have a number of, or we have a number of investors, and we are working for a number of companies that use different types of solutions that we offer. Some of those are using the MPC-based key management system that we've been building. Yeah. Oh, I didn't know that was. I don't know. So anyway, so my name is Jakob, and thanks for all the care in trying to pronounce it correctly. I did my PhD at the University of Aarhus, and after that I worked for a place called the Alexander Institute, which is kind of like Fraunhofer in Germany or the MITRE in the US or something. It's like a private research organization, but it's kind of with an applied flavor. And we've been doing applied cryptography there for many years, working together with the cryptography group at the University of Aarhus. One of those infamous papers is the sugar beet auctions, which I'm pretty sure that everybody in MPC is fed up with hearing about now. But on the back of that, we actually founded the company Partitia. And then after a few years trying to commercialize MPC-based auctions, which was not a great success, we founded Sepia, which is basically using MPC, multi-party computation, to do key management. We had some ideas about how to leverage that for cloud-based security and other applications in the beginning. It turned out that we were a bunch of geeks that didn't know what the market wanted. And then the market came to us and said the market wants blockchain stuff. And so here we are. Another thing I had a small stake in is founding something called Partitia Blockchain, which is a level 1 blockchain for orchestrating MPC computations. In theory, you could take the work we did back in 2008 and then you could run it on this network. And this is something which is live now, and you can Google that and find more about it. And now, since 2 years ago, I've been working for Blockdaemon that acquired Sepia after we spent some years trying to build a business. I'll talk a bit about that, how we talk about MPC and some of the problems we see in MPC-based key management. So for us, when we communicate with people, we have kind of this MPC in a nutshell. So everybody here who worked in research in the area knows the millionaire's problem. And as you can see, I'm not sure any of these are the richest person. I don't know. They were 10 years ago when I made this slide. So the idea is here you can compute the value of any function. It's like FHE really, but in a kind of a different setup. You can compute a function without revealing anything about the input. And this gives you some very nice properties, and you have well-defined security models and assumptions and so on and so forth. And so this slide is really about communicating the core idea of being able to compute any function, and that it gives you, and I think a lot of the people we talk to, the interesting part here, right, when we talk to them about what is the security they get, it's the same type of security that they're used to. For instance, typically when you're doing ECDSA, it assumes that ECDSA is secure. It doesn't, necessarily throw all kinds of weird stuff into the box. Yeah, and then I'm not sure where this realization came from. Maybe it was some of the Unbound guys. But the idea basically is that you can view keys, cryptographic keys as secrets. You can secret share them, and then you can use MPC to do cryptographic operations. So it's really a simple and elegant idea. And then obviously you have these properties. For instance, if you're doing mere secret sharing, you're going to split it into a key into a number of shares n, and then you have a threshold t, so that you always any T players cannot reveal the secret or get access to the underlying key. And this is, this is confusing for people because people compare this to multisig, and it's always confusing. Is it T or is it T+1? So, but that's another matter. Yes, so that's threshold cryptography. That's what it is. I think NIST is also using this term now. They have this project about how to do MPC-based key management, and they're using the term threshold cryptography, so that's where I had that from. We have two products that realize this. The first thing is called the Builder Vault. It used to be called the TSM, so on this slide it's called the Builder Vault TSM, and this here shows its architecture. So basically, you have a number of MPC nodes, n. In most cases we work with, n is 2 or 3, and t is thus 1 or 2, depending on kind of the parameters. We do have one application where we are running one of our protocols, an honest majority protocol for ECDSA signing, with about 1,000 nodes. So it can scale. If you talk to our marketing guys, they will tell you this works for any choice of n and t. And as normal, when we talk to the customers, it's more like, yeah, as long as n is 2 or 3 and t is kind of like, so it does scale to some extent, but there are a lot of details to be worried about. One of the things we also offer is the ability to have, in the beginning it was 1, but now it's really any number of the nodes can be running on a mobile device. And that has its own challenges in terms of the network connectivity, the timeouts, and all kinds of practical issues you get into when you have a protocol that will typically run over multiple rounds of communication. But it is something that works also with the ability to have a setup where you're only using mobile nodes to do the MPC protocols. One of the things we have done is that we have taken this architecture and then we've kind of shrink-wrapped it into something we call a policy authority. I'll get back to that shortly. But really this, in the end, there are a lot of moving parts here, but really the interesting part is over here where we have the MPC nodes, which will do key generation and signing for the different types of blockchains that this wallet architecture then integrates with. From our perspective, we have this box here. If you ignore the air gap stuff, it's a kind of a copy of that with some other properties. But in this box, we don't assume anything about the security of this thing over here, right? The wallet, it has addresses, it knows users, it knows all kinds of things. But in terms of security, all the keys are generated inside the box on the top right, and all signing happens inside there, so everything is under the threshold security policy. And even users, we have like third-party approvers with mobile devices. they also live in the same closed ecosystem, so that we're sure that there's not a single point of failure outside of this box. So based on that, the stuff we did with the Builder Vault and the stuff we've done with building our own wallet, we're kind of seeing some trends, and I think many of you will probably recognize these. It's not rocket science as such, but it is the actual problems that are out there, and the actual trends are kind of the hard nuggets when you're doing MPC-based key management, in particular for wallets. So the first one is policy enforcement. So a typical problem when people are building MPC-based or threshold security wallets is that they have this nice secret sharing of the private key. They're doing fully distributed signing and key generation and whatnot. And then they have a policy layer which is not under threshold, right? So you have a single point of failure outside the system. And then the MPC layer will effectively blindly sign anything you send to it, right? And so you kind of, in some sense, if you have an existing policy engine and you like that, it makes sense from a kind of practical security point of view, but from kind of a more purist point of view, it's no longer MPC security, right? Because you just need to compromise the policy engine. So what we have tried to do, and I'm following these trends because it's things that we're trying to put into our products now, but I'm sure a lot of things will evolve over time to give, we're trying to build even better solutions, and I'm sure others will try so too. But the idea is that the policy enforcement happens inside the actual MPC node holding the key share. So each MPC node holding a key share will also have its own view on the policy that's being evaluated. And that means that each MPC node in the system will need to know all the external approvers. If you have like a quorum with 2 out of 3 or some number of users that needs to approve a policy, then they need to be in the same ecosystem. On top of that, some of the things that you could do in our solution, we have the backend nodes that are on the threshold security. You could move it further out and have the quorum. If you have a set of approvers, you have these rules where you need 2 from this group or 3 from that group to approve a transaction. That you could do the MPC-based signing all the way out to those mobile devices or whatever, using generalized access structures or approaches like that. We have not seen a kind of a commercial pull for that type of solution, and I also think that from a practical perspective, maintaining replicated secret shares keys across a big number of users where there's some churn in the users who are using the system, this will be painful for our customers to operate. Another trend we see is cold wallets. So that's something which is a necessity for a number of regulated wallet providers. And what we see is that people want to have the same type of threshold security for their cold wallets as they do for their hot wallets or the warm wallets. So it means that you want to do MPC signing with nodes that are not able to communicate with each other. Maybe they're allowed to communicate with each other during key generation, maybe they're not. Some of the things that we're looking at is using stuff like partial signatures. You mentioned pre-signatures before, the fact that in ECGSA you can pre-compute a lot of the rounds, and then you don't need to do be online for the signatures to take place. This doesn't solve, you still need to bootstrap it, so you can, in our system, if you really want to, you can actually do a kind of a sneakernet key generation protocol. If you have the time, in particular to educate the users who's actually going to do this, to do key generation in a way where they're manually using USB sticks or whatnot, carry messages back and forth between the different nodes. That's a possibility. I think what it turns out for us is that one of the big chunks is really making this system usable, right? So finding out what's the right trade-off between, or the classical trade-off between security and usability. Because if you want full threshold security, so what we typically do is that for key generation, it's acceptable for the nodes to be online on a closed local area network maybe. And then after that, you've generated a bunch of pre-signatures, and then you can do partial signatures after that. So stuff like that. Also key things like how do you ensure that you have proper backup of the keys which are distributed across a number of offline nodes and that type of thing. So there are good solutions to be found yet in this space. Another thing is HD wallets. So if you look at stuff like Bitcoin, something called BIP44, which means that you have this hierarchy of addresses to make it easy for a customer to publish addresses without reusing the same address all the time, and make it easy for them to find out which private key they need to access those coins. So what BIP44 is an instantiation of something called BIP32, which shows how to build this hierarchy. And when you're doing this derival from the kind of the master seed or the master private key, then you're doing derivation, which can be done in two ways. It can be done in what's called hard derivation, or you can use soft derivation. So the difference between those two things is that hard derivation is taking the private key as input to the hash function. So if you're doing MPC-based HD wallets using BIP44, it means that you need to do general purpose MPC because it's an asymmetric primitive, and I mean, at least I don't know any way that's more efficient than doing general purpose MPC. So that's slow, and typically it's too slow. Sometimes if you know that in BIP44 you do pre-generation for the top 3 layers, and if you know exactly which coins and blah, blah, blah you want to support, then you can pre-process that if you have time before you publish the wallet. But it's slow and it's costly. We're talking to customers that want to do this on mobile devices, and right now it simply doesn't work because it takes too long. And that's really how we started when we did the sugar beet stuff. It's like you sit down and then you do tricks and hacks and whatnot and try to figure out a way, can we do this better somehow? Can we maybe loosen if we have like a dishonest majority, can we maybe temporarily switch to an honest majority setup, or can we do something else, and what makes sense, and what can we communicate to our customers, what works, what's performant enough. So there's really a lot of stuff. I mean, from a security point of view, we're completely happy with soft derivation, right? But customers, they have existing wallets they want to import, and they want to give their customers the ability to move to another provider if that becomes a problem. So it's not something we decide. So I'm thinking better solutions are required here as well. The fourth trend I want to talk about is trusted execution environments. And it's not something as an MPC software-based security person that I've been comfortable talking about. But I think maybe half of our customers, in particular those that come from traditional finance, one way or the other, they want hardware. They want, they want this. They're saying, do you support Amazon Nitro? Do you support SGX? Do you support AMD SEV or whatever? They want it. It's a check mark that they need for compliance and maybe also for practical security. So it's something you need to do. And the challenge from our point of view, is really, I mean, Amazon, they have this natural platform which they say you can just take anything and run it inside, and that's true. But if you do that, then you really don't get the full security. You need to do remote attestation and all kinds of things and make sure that the whole key management setup makes sense. So it's costly. And then you have customers that say, okay, now we want to run this on Google instead, so we want AMD SEV, and they have a different way of doing remote attestation, and the security model is slightly different. So, and then, yeah, then you talk to the marketing people, and then you really need to be careful about the statements you make and how you get this whole thing set up. So I think trust in the execution environments is a benefit for compliance. It's a benefit for hardening as well. Let's not neglect that. But it's complicated. It complicates life. I mean, the nice, simple security assumptions that I was kind of brought up with from my time in academia, they no longer exist, right? Because there's so many practical things going on. The final thing, the final challenge, third-party validation. I mean, software has errors. I think it's pretty common. We see that all the time. We try to do the best we can, but what we really have is that we have simple cryptographic primitives like ECDSA, EDSA, RSA, AES. And maybe AES is not that simple, but it's well understood. And then you build complex protocols to implement those rather than just implementing them, right? So you get something where it's a lot easier to make mistakes. And that it is what it is. You can do formal verification. You can do standard validation in frameworks. I'm not saying that actually improves security, but it gives your customers confidence that you know what you're doing. And it also checks off some compliance requirements. We're trying to get FIPS 140-3. And how can I put it? The fact that everything needs to happen within the same physical security boundary kind of makes the whole MPC model complicated in a FIPS world. We're doing third-party validation. We had NCC group a couple of times reviewing our implementation, really doing two things in parallel. One thing, checking up against the research papers, our own, others that we've implemented, that the software actually implements those correctly. And two, that our software does not have any traditional errors in terms of missing input validation or whatever it could be. The final thing, and something which is quite popular, is open sourcing. So you give it to the community, and the community ensures that the quality of the software is good. So I'm a big believer in that, but there's an assumption. There needs to be an ecosystem. There needs to be a community that can actually do this. Otherwise, it doesn't work. For OpenSSL, stuff like that, it's great. For us, I don't think we can rely on that necessarily. You need to build an ecosystem, and that was not our take from the get-go. It's something that you can always discuss what is the right solution, for us at least. Yes. So what we're seeing is that everybody that who's doing wallets, they want MPC. Some of them understand what it is. A lot of them understand that it can improve the security. And I think if you look at the wallets, I mean, today we had some very sophisticated protocols, but if you look at the MPC wallets out there, the kind of the basic problems are solved. You can do ECDSA and the other primitives that are relevant. And then I think what I've talked about is some of the more advanced features, and those are not advanced features for people who are used to using wallets. They're advanced features for people building MPC protocols, right? So, yeah, and what people are looking for when they're buying this type of product is that they want people who have the right pedigree, they want solid engineering, and they want compliance. So yeah, there's no dark magic as such, but that's what I think is going on. Thank you.
Thank you very much, Jakob. If anyone has any quick questions, or if not, oh yeah.
Thank you so much. I'm a researcher from Israel. I would like to ask about why a Danish sugar beet auction use case is not being out by the industry.
Why not commercially? Yeah.
I heard that's a brilliant use case, and that's
Yeah.
one of the first.
So what happened with that? Maybe there's a conversation for beers, but really there was a change in the regulation in the sugar beet market. Is like so basically it's like production rights, like fish quotas. So these farmers, so they were all across Europe, they were changing the regulation. So the farmers, they needed to reallocate these production rights to the places that were more efficient. And that happened across all of Europe at the same time. So we built a solution for the Danish market, solve their problem, and then we tried to solve it. We were in Cambridge, where the UK parallel takes place. But they found another solution because they had the same problem at the same time. So it's like a 1 year, time hole where you could get into that market. And we spent that year and a lot of time up to it building a solution for the Danish market. And then once we started looking at the rest of the world, they solved it in other ways.
What was the other way? Trust that party? Or
what?
What was the other way? Trust the third party?
Yeah, exactly. Yeah. One way or the other.
Exactly. I mean, it was solved.
Yeah, a lot of fun stuff about that. Yeah.
Great. Thank you so much, Jakob. We're now going to have a lunch break, and we'll see everyone back here in around 45 minutes. Thank you so much.